Hi everyone. I'd like to do a quick video about vise stops because as you can see I've got a piece in the vise here and I've got 9 more just like it right there. And what I'm trying to do is this little doodad. I've got to cut it to length and I've got to drill a hole there and 2 tapped holes there. Since I've got to do multiple pieces, and even if you have to do just one piece but multiple setups on that piece and you don't want to lose your datum, your reference surface, then using a vise stop is incredibly handy. Now this is one that I recently made and it's going to be the subject of a future build video. But the nice thing about this one is you've got this dowel pin here that you can slide in and out, and it's held on by 2 set screws here. So you can actually position the vise stop there and have your part far enough away from it. The pin is actually below the surface of the vise jaws. So you can machine all the way around the part. This style also allows you to find your edges a little bit easier because your part's not bumped up against a solid stop such as this one. These are quite handy, but I like this style just a little bit better. So just to show you, it's held on by 2 set screws that bear against the back jaw of the vise. And I'm going to go ahead and tighten that down now. So as you can see, the back edge of my part is up against that pin on the vise stop. And what I'm going to do, and this is the way I do it with any stop situation, I'm going to bump all my parts up against that pin. I'm going to touch off on this surface over here by the end mill, and I'm going to make that pass at the same setting on my digital readout on every single part. Then I'm going to deburr them, I'm going to turn them around and set that against the pin, and take my first pass on the first part, measure it, see how far I need to go, and then at that point I can just go ahead and make that pass on every single part, and they should all be within a thousandth or two. So I'm going to turn on the machine and touch off here, and I'm going to move in a little bit and make my first pass. Now I set up a stop on my saw as well, so all of these blanks should be well, pretty darn close as far as the length goes. Certainly close enough that I could take 15 or 20 thousandths off of this side and clean up all of them. I cut my pieces about 1/8 of an inch long, or 3 millimeters for the metric folks. That gives me plenty of wiggle room to take passes on each side and then still have enough to measure and take off an appreciable amount. So there's my first pass on my first piece, and now I just got to do it 9 more times. Notice I crank back across the part to make sure that I'm set up to do a conventional milling pass on the next part. So I'm going to do these in real time just so you can see how fast it is between each of these cuts. That's bumped up against the stop, and here we go. That was all of about 1 minute for 4 cuts. So at this point I've got all of my pieces cut on one edge and I've got them deburred. So I'm going to take that nice machined edge and bump it up against the stop now. So I should be able to just move in another 15 thousandths and I ought to clean up this edge. Then I can take a measurement. Alright, here we go. I'm going to re-zero my digital readout because now this is the edge, this is my datum surface, and I'm going to take a measurement now and I'll be able to say, okay, I'm such and such amount long and I can move in that amount. Here's the really nice thing about this type of stop. Since I've got that pin there and it's below the vise jaws and it spaces the part away from the body of the vise stop, I don't have any interference and I can get in there with my micrometer and make a measurement. I'm about 97 thousandths long. Now if you were using a stop like this where your part was actually bumped up against the stop, unless your part is significantly bigger than what I've got here, then you don't really have the opportunity to get in there with a measuring tool. Now since this is brass and because the length doesn't matter a ton on this piece, I just took all of that in one shot. So let me take a measurement and see where I ended up. And I'm about maybe 6 or 7 tenths under my nominal size. Certainly good enough for this part. So I've got my first part cut to length, and that's got my settings set for all the other parts. So all I'm going to do is bump my machined side up against my stop and make all of my cuts at the exact same setting of the table. And I'm going to do this in real time so you can see how fast it goes. There we are. I've got all of my parts cut to length now, and I've checked them all using my comparator stand. I went ahead and made a separate video of that showing how to use the comparator stand, and I'll put a link to that in the description. Now what I'm going to do is find my edges, and I'm going to find the edge against the vise stop, and then I need to cut a slot down the middle of this piece, so I'll find the edge back here, I'll find the edge over here, and I'll split the difference and call that 0. Now I know exactly where the middle of my piece is, I know exactly where the edge of the piece is, and all these things are constrained by the vise and the vise stop. So from here on out, I can cut every feature of this part, and I don't have to find the edges on every single piece, which is a massive time saver. Especially here I'm just doing 10, but if I was doing 100 or 1,000 or 10,000 of this part, that would be an absolutely huge time saver. So right now I'm going to go ahead and cut the slots in all 10 pieces. That's so I don't have to remove my end mill and I won't lose my Z location. Okay, so this is the last of the parts that I need to cut the slot in. And what I'm going to do is take the full depth, which is 230 thousandths, or just shy of 6 millimeters, and then I'm going to move over 10.5 thousandths each way, and I'm actually going to take a climb cut on this. It's brass, it's a carbide end mill. I've made it through that way with the other 9, and it's worked just fine. What you'll see is that I'm going to use a pretty much constant stream of air on it to evacuate the chips, because nothing kills a cutter faster than heat and obstacles, and you get both of those with chip buildup. So I'm going to run straight down the middle of the part and then offset 10.5 thousandths each way, and I am using the power feed on my mill. Okay, so that's my finished slot. What I'm going to do now is change over to the drill chuck. I'm using an 1/8 inch center drill as my spot drill, and then I've got to go ahead and drill it with a regular drill after that. Now what I'm doing on this hole is I'm going to go ahead and spot each of the pieces first, then I'm going to change to the regular drill and drill each of the pieces. You could also go ahead and change your tools instead of changing your part. So you would spot, change to the drill chuck, and drill. It's really 6 of one, half a dozen of another. Either way, you're either changing your parts or you're changing your tool. In this particular part, I would end up changing my tool a lot more often than I would change my part. So I'm going to go ahead and do it this way just to save a little bit of time. So this is my last piece for spotting, and I want to point out some other things about this. If we're talking about production techniques, let's also talk about ergonomics. It's not just about using a vise stop to make things quickly. I've got my quill stop set so that I spot the same depth each time, and I've got my air hose right here within easy reach, so all I need to do is drill it, turn the machine off, and go ahead and blow it off. And it just makes things a lot faster when everything's in easy reach. And that's how fast it is to do it. Now I'm going to go ahead and drill all of the spots that I made with a number 31 drill. This is to fit a 3mm pin. So I've got to make 2 tapped holes. They're both 632. One's going to be intersecting with that hole that we just made, and the other one's going to be over here in the middle of the part. Unlike the last operation, I'm going to go ahead and spot drill, drill, and tap while the part is in the vise. I'm not going to change parts constantly because it's a tapped hole and I don't want any misalignment whatsoever. I went ahead and drilled deep enough with my center drill that I'm going to have a chamfer for the tap. Since this is basically a blind hole and it's a 632, which is a very easy to tap to break, I'm just going to turn this by hand so that I don't run the risk of breaking it under power or running it into the other side of the hole that this is intersecting with. And once I've got it established, then I'll go ahead and back it back out, and I'll finish this up by hand later. For the last operation, I've just got to drill and tap another hole right here, smack dab in the middle of the piece and in the middle of that slot. And I'm going to do this the exact same way as the other one. Now this one is a through hole. I could tap it under power, but it would be a lot of speed changes, so I think I'm just going to go ahead and tap it by hand just like the other one. I'll start it with the tap in the drill chuck and then just finish up by hand after I get it out of the vise. And again, that's just because I don't want to constantly be changing my belt position around or changing between high and low speeds. It's just going to be a whole lot faster this way. There we go. I'll do that for the other parts, but I think by now everyone's probably got the gist of how the vise stop works. I hope you found this video helpful, and if you did, please consider hitting the subscribe button below. And please do check out some of my other machining videos. Thanks for watching, and I'll see you next time.